Hello everyone. So in today's video, what we're going to do is we are going to make a math animation, but using the AI technology ChatGPT. So first I'm going to explain what I want to animate, and after that we'll ask the same thing to ChatGPT and expect it to, you know, do the coding for us. So we're going to be looking at parametric curves, especially only in 2 dimensions for now. So for example, we have what? So these are parametric curves, examples of parametric curves. So usually what we have in parametric curves is like we have a parameter. So here we have the parameter t, which goes from 0 to 2 pi, and a parametric curve is represented by an equation like this. Okay, so what happens here is the x coordinate, it takes the value 2 cos 3t as t goes from 0 to 2 pi, and the y coordinate takes the value 2 sin phi t as t goes from 0 to 2 pi. So the x and y coordinate together, they form a set of points in the 2D plane as t goes from 0 to 2 pi, which will form the curve called, which we call a parametric curve with the parameter t and parameter domain 0 to 2 pi. So what I want to visualize is that I want to really see the cos function and the sine function acting behind this parametric curve. I want to see the cos wave and the sine wave, which is not visible right now, but which could be brought into screen, which could be visualized if I do a really cool trick, and I'm going to explain that how to see the cos curve and sine curve within this parametric curve, and that the trick is to add an extra dimension. So let's start with something simple. Let's look at the unit circle, which can be parameterized as what? Cos t sine t as t goes from 0 to 2 pi, right? We shift to 3D and we add an extra equation which represents the current curve, but the trick is to put the first or any one coordinate must represent the parameter variable, right? And the other two coordinates must represent our curve in 2D, which was cos t and sin t, right? So it can be interpreted in a way that this can be considered as the x-axis, this can be considered as the y-axis, and this is the parameter axis, so t-axis, right? So as t goes from 0 to 2 pi, x first takes the value 1, then x becomes 0. When the curve reaches here, x becomes 0. Then when the curve reaches here, x becomes minus 1, goes back to 0, and goes to 1. So when we compare the x values, only the x coordinate values, with respect to the parameter values t, so comparing the x coordinate with the t coordinate, what we get is a cosine curve, which starts at 1, goes to 0, goes to minus 1, goes to 0, goes back to 1, as t goes from 0 to 2 pi, which is nothing but the cosine curve. Similarly, when I compare the y coordinate, so when the curve starts, the height is 0, the y coordinate is 0, and then the height becomes 1, goes back to 0, goes to minus 1, and goes back to 0 when it reaches back to the starting point, right? So when I compare the y coordinate with respect to the t coordinate, we get the sine curve, so which is natural, since here we have t, here we have sine t, which represents the y coordinate. So of course we should get the graph of sine t. So this is what I want to visualize using ChatGPT. Let's say creates a 3D parameterized curve. Okay. So it's using calling the function parametric function, which is not actually defined in Manim community edition. So I'll ask it to avoid calling the function parametric function. Okay. Show creation won't work. Also reset camera in the end. show creation won't work, so okay, I'll correct it in the code. Okay, so let's see if this works. I'll copy it and I'll make a new coding document, paste my, so instead of using show creation, which will not work, I'll simply use create. Okay, and let's see if this works. Okay, save, and we run it. So first we'll run this and then we'll run this. So it's giving me something. Okay, okay, okay. So it didn't add the access, so I'm going to ask it to add the access for us. So add access. So it understood that it needs to add a 3D access. Okay, which is really wonderful. Okay, so actually I don't need to change everything, but still just the part involving the access was enough, but doesn't matter. So this is the new code. Again, I have to change this because show creation won't work. So we have a similar function which works, which basically does the same thing, which is the create function, and let's see what this does. Okay, so this is our cost design T. It adds an extra dimension. The XZ plane and YZ plane are not quite right, which is okay, which we can correct. So for the XZ plane, phi will be minus 90, and we need to rotate the Z axis, which is not usually rotated when you animate. You know, Z axis is always fixed. So this is rarely used. The gamma angle is 3m, right? Okay, gamma equal to 90. Sorry, gamma must be minus 90. We need to rotate it clockwise, right? Okay. So instead of using distance, let's use focal distance, which I'll explain later. Okay, why we are using it. And theta will be, I think, minus 270, I guess. Either minus 270 or maybe plus 90. Let's see, plus 90 first. And this will again be, the only change will be in theta. So it will be, I think, minus 180 or 180. It's either minus 180 or plus 180. And to reset the camera, it doesn't matter. It's all, let's put everything to be 0. Instead of using distance, let's use focal distance. So the camera does not move far, camera stays there, but the focal distance, it's like the curve will not bulge with respect to the distance, right? It will be more projected per se. So let's see what this does. is our curve. Okay, this is the cos curve. Cos was right. Sine curve is not actually visible. And it's rotating too much, right? So I can... okay, so there are two things that I need to do. First, I need to reduce this rotation by subtracting 2 pi to the angle. So it's the same effect, but one rotation is avoided. And next thing I need to do is this transformation is not quite visible because it's rotating like this, and so you cannot really see what's happening. So let's fix that. So it's minus 360 would be minus 270 as I mentioned earlier, and then we want one more, right? To really see the transformation from the xz plane to the yz plane is not quite visually satisfying. So let's add an extra camera moment. So something near 90. So let's put it 30. Let's put this maybe something between 270 and 80. It would be 200. 90 and minus 90. Let's put again 30. And let's give some runtime also for creation. Runtime equal to say 4 seconds. Equal to 4. Equal to 4. Okay. Resetting. Fine. So let's save this and let's see if this works. So I can change the angles if I want by saying, okay, I change this angle, change the angle to this particular degree, and ChatGPT, I guess, will just change the particular angle. It's really not that much of a big deal if I do it myself, right? But the point of the video is to really tell how much can the AI contribute to simple coding, right? So this is the curve in projected onto the 2D plane, and okay, that's the cosine curve, and then we have the sine curve. Beautiful. So that's what I wanted, and then it resets the camera to the original position, right? So let's do some okay, cool. Okay, so the next thing that I'm going to do is I'm going to try to change this parametric curve. Which parametric curve? Where is it? It's gone. 3 cos t. What was it? No, 2 cos 3t, right? 2 cos 3t and 2 sin 5t as far as I remember. Okay, so this is what I want to visualize now, right? This is where we started. What I'm going to do is I'm going to copy this code and I'm going to tell Manim, this is the code what I really wanted, and can you change the curve to any given curve. So I'm going to copy the code and I'm going to tell Manim the correct code is, and I'm going to paste it, and okay, so it understood the difference that I made, and now can you use a similar code to sin 5t comma t, right? This is what I really wanted to see. So like once I to tell it, okay, this is what I want, this is what I am expecting. So it really understands what I'm trying to reach, what I'm trying to obtain here, and then that's what I wanted to. So this is really, really, really amazing. So let's see how much of this actually works. So, so it has automatically put used create instead of show creation, and everything is the same except the function. And let's see how much. Python environments, of course. Okay. So I don't know if the focal distance is enough, because this is a bit more complicated curve, right? What we have is a bit more complicated curve. So let's see. I'll explain what I mean. Okay, this is not quite good. See, this is what I meant. Okay. So many things to correct. Not many things, just like 2 things. And I'll explain what it is. First I need to increase the curve points. 0.001 maybe. And okay, then I need to increase the focal distance. So the more focal distance is increased, the more projected the curve is, right? So the less bulged out the curve is, right? So let's see what this does. I think the 0.001, the number of points, that's what's taking so much of time, I think. So just ChatGPT could be used like in a similar way for anything. For example, if you want to visualize a linear transformation, and if you want to visualize anything that you usually visualize using Manim, you can just if you even don't know much about the programming language yet, you just know the basics. Then also you can really use this technology to visualize the things that you study. Anything from integration, from vector fields to differential equations to transformations, anything. I think it will be really. See, this is the curve that we wanted. It's projected. Okay, so since the focal distance is increased, it's more projected, and we can see the sine curve and cosine curve. So when the x coordinate, so here what's happening is we have the function cos 3t and sin 5t, right? So the x function compared with the t function, so xt compared with t, x-axis compared with the t-axis, is going to give me the graph of 2 cos 3t. So as t goes from 0 to 2 pi, 3t goes from 0 to 6 pi, okay? And as t goes from 0 to 2 pi, 5t goes from 0 to 10 pi. Okay, so there will be a frequency difference between both these curves, and there will also the length, the maximum and the minimum, the extreme values instead of being -1 and 1, it will be -2 and +2. So it will be elongated curves compared to the usual cosine and sine curves. Okay, that's really visible here, right? So first we have we compare the x coordinate with respect to the t coordinate. So we get a cosine curve which reaches twice the height of our earlier curve. Okay, and compare the frequencies. The cosine curve will have less frequency than the sine curve, since it's cos 3t, and the other one is sine 5t. So the sine curve will have more frequency, yes. And so there it is. So you can do this animation for any parametric curve. Okay, now transform. Okay, so I'm just going to leave it here, and I'm going to use the code to visualize more and more parametric functions, and I'm going to make a separate video just involving maybe 7 to 8 parametric functions, parametric curves in 2D, not just using cos t and sin t, using maybe t squared and log t. So t squared will give me the graph of a parabola, and log t will give me a downward graph, and all kinds of graphs can be visualized. And this is the code that we have obtained from ChatGPT, which is really, really impressive. And that's where I want to end. Let's just play that once again. Okay, so this is the final video that we made, and it's the end of it. Thank you. See you all in the next video. Enjoy.